Okay, first off, I apologize if you hear some noise in the background. I can't seem to get my kitten to stop purring. Not a bad problem to have. Anyway, the goal of this lab is to try to analyze some of the effects of plate tectonics and use that to figure out what direction each plate is moving and what type of boundary is between the plates. So for example, if I wanted to find out what direction this Cocos plate is moving, I would first want to identify what kind of boundaries are between it. And so I would first try to figure out what's going on between these two plates. To do that, we need to remember what's happening at the plate boundaries, because that's going to help us figure out first what kind of plate boundary it is, and that's going to help us figure out what direction each plate's moving. Let's remind ourselves what happens at each type of plate boundary. So we have two types of convergent boundaries. They're moving together. Subduction, one plate goes under because one plate is an ocean plate and can fit under. Collision, both plates go towards each other, but up because they can't fit under each other, so they crumple upwards. Divergent boundaries apart, and transform boundaries sideways. Notice they all have shallow quakes. So having a shallow earthquake helps us identify where there are plate boundaries, because earthquakes occur at plate boundaries, but it doesn't help us identify what type of boundary it is. For that, we're going to need to look at the other stuff. Let's start with why we also see medium and deep earthquakes at subduction, but not at the other three. To understand why earthquakes occur at different depths, we need to look at the temperature profile in the plate. So we can look closely at this plate, which shows a sideways view of the lithosphere. Along this edge over here is very near a divergent boundary. And then the general bulk of the plate, the lithosphere, we see this kind of pattern throughout, that the top part is colder, in the blue here, and the bottom part gets hotter. But also notice the labels that we have here. Brittle means that it does not deform easily, and so when there is tension or stress or compression, it's likely to break, and we tend to have earthquakes. Ductile, recall, means that it can be bent or deformed a little bit. So when there's tension or stress, it tends to be able to handle that without causing earthquakes. So returning to this chart, we now know that shallow earthquakes occur everywhere because that's where there's brittle crust that can deform when the stress of plate tectonics happens. So we see that at all plate boundaries. But we see the deep and medium earthquakes only at subduction zones because of the temperature of the plate there. If we take a look at the temperature differences that we see in subduction, notice that in subduction, the top of the lithosphere along here, as it subducts, so this plate on the left is subducting under the plate of the right, and as it goes down, the temperature between the two plates stays cooler. We're talking warm temperatures. We're still talking 600 degrees Celsius, but it's much cooler than the bottom of the lithosphere, the ductile part that we see over here, and definitely cooler than the asthenosphere. So as we take a look, this 350 degrees that we see down here continues onward, and so that continues to be brittle. And so when we take a look at why we see not only shallow earthquakes, but medium and deep earthquakes, it's because of that temperature difference. And so we see that along the top of the plate, where it remains cool, there's shallow earthquakes. But in subduction zones, when we get down here, it's still cool and brittle. And so we can see earthquakes at medium depths and at deep depths. So having that range of earthquakes of shallow, medium, and deep is a good clue that we're looking at subduction. The plate boundary is over here, but as it subducts, what happens is some of this part of the lithosphere gets warmer and warmer, and as it gets warmer and warmer, we see that it starts to melt, and that lithosphere has some water in it from groundwater and such, and that makes it less dense, and so the melted lithosphere rises up slightly off-center from where the boundary is and causes a volcano. So that's why we see that subduction zones have shallow earthquakes, but also deep earthquakes and volcanoes. And then remember from our drawings that that's where the trenches are, as that one plate plunges under the next. collision zones are also types of subduction, but they're of two thick lithospheric continental plates. And so as we see what happens there, as one plate comes together, neither plate can slide underneath the other one very well. And so a little bit of the bottom of the lithosphere goes underneath it. That tends to be so far underneath, and it remains warmer and ductile and able to deform. And if you look at the temperatures where the collision happens and we get that folded up shape of the mountains, we see the temperature remains pretty cool by comparison. The ductile zone is really just up here. And so we have shallow earthquakes, but we don't have any deep ones. And because neither plate can slide underneath the other one, we get some folding up or crumpling up of the crust, and we get those folded mountains. Okay, when we look at divergent boundaries, we can see that the temperature, as we said before, along the surface remains relatively cool. So it's only near the surface where there are temperatures that will cause the rock to be brittle and lead to stress building up and causing earthquakes. So that's why they only have it near the shallow area. Don't forget that we can tell divergent boundaries because they have ridges. Finally, when we get to transform boundaries, they also have shallow quakes because, once again, it's only cool enough to be brittle near the top, and that's where they're touching each other to build up stress and cause an earthquake. So it's not real easy to tell from just the effects of seismic activity there, but we can tell by the arrows. And I will give you an example of that momentarily. So how does all of this information help us figure out what type of plate boundary we have or what direction the plate's moving? Just to remind ourselves as we look at this map, we have convergent boundaries. Those are the ones that are coming together. So I'm going to do an arrow that they're coming together here. And I'm going to identify what types of things I'm looking for. So it's subduction. So I will find not only shallow earthquakes, but I'll find medium earthquakes, and I'll find deep earthquakes, and I'll find volcanoes. And so convergent boundaries also includes folded mountains, so I will see that symbol on my map too. A quick note about volcanoes, and that is that hot spots, they're a volcano that is not from plate tectonics. So they involve rising of magma in a region that's not from magma melting during subduction. Quick side note, this part shows it here as hot spots, and technically they are, but that hot spot is actually causing a rifting zone. Eventually, this section of the plate will pull apart from the African plate, and so it's rifting right now, so that's technically from plate tectonics. But in this lab, we're going to kind of just ignore that, and we'll just consider them a hot spot. Okay, so when we look at divergent boundaries, remember, they only have shallow quakes. But remember, these guys have ridges too, and we learned about where there's some seafloor spreading, and so that's going to help us a little bit. Finally, when we look at transform boundaries, they also have shallow quakes, and we're mostly going to be looking at where we have them moving side by side once we figure out some arrows. And I forgot to draw arrows here. These two, remember, are moving apart. All right, so it really works best if you color code these. So I'm going to fill in my little key so I can remember. And I want to look at the Cocos plate. That's this plate here. I want to see if I can figure out what direction it's moving. And the easiest way to do that is to find subduction zones. And notice here, I've got shallow earthquakes. And as I get a little bit closer to the trench, I got some medium earthquakes. And then I have mostly volcanic mountains further in and deep earthquakes along here. So this boundary right here is going to be a subduction zone. I'm going to trace that in the color that I chose, which is red. Since it's a subduction zone, I know that that means these plates are coming together. So depending upon whether I decide this plate underneath it, Nazca plate, is moving this way, or if I decide it's moving this way, or that way, or Remember, they can go at an angle too, so this doesn't have to be going just left, right, up, and down. So based on what I decide this plate is moving, I will know then what type of boundary I have along here. So if I decide the Nazca plate is moving to the right, it's a transform. If I decide that it's moving to the left, that's also a parallel motion, so it's a transform. If I decide that it's moving upwards, well, in this plate, it's going to be moving into that place, so that might be a subduction boundary. So knowing how these two plates move helps me figure out how the one side by side is. Okay, so your goal is to figure that out for the entire map. I highly, highly, highly recommend that you do that first before you go on to the lab. The lab on Canvas is called Seismic Evidence of Plate Tectonics, and it has questions. And if you have figured out what type of boundaries you have everywhere and you put some arrows in, the online part should go really, really fast. Okay, once again, do the map first, and then the assignment that goes with it is on Canvas. And you will find it in our Plate Tectonics module, and it's at the bottom of the assignment section. So here's the assignment section. It's this one right here, Seismic Evidence of Plate Tectonics. If you finish, please remember that on Monday is our assessment on plate tectonics. It's a short unit. And so we have all of these resources to help you review. So I've got a Kahoot, a quizzes, and a study guide. So make sure you come to Monday's class prepared to take the assessment. Remember, looking over notes is not a good idea, so use one of these resources. If you have any questions, you can come into resource on Monday.